All right, Chad, how are we doing tonight? It is another Math Man Monday, and tonight we are presenting implicit differentiation. If you were tuning into the stream, I'm sorry, we had a little hiccup there where the stream kind of dropped there for a second and I had to reboot it. So apologize that ahead of time. If you're digging the new board, I'm using, this is a Onyx Deco board using neon markers, and I'm also going to be using the other Deco board I got from Deco today that's supposedly might be a little bit better just for our camera usage. So we're going to try that out, and if you ever have any questions about Deco boards or interested in them, hit me up, let me know. I can give you some contact information, and hopefully that'll help you guys out. So to continue off where we left off last week we did derivatives. We talked about power rule, quotient rule, and product rule. So this week we are going to do implicit differentiation, which isn't too terribly different than what we did last week. We're just going to add in a couple extra steps. So last week, the one thing we talked about was if we had something simple. So for instance, we talked about y is equal to 3x. And if we wanted to find the derivative, I mentioned last week that when you take the derivative, on this side, we end up with 3. And I believe I said, hey, for now, just know that this is dy dx. Okay, well, implicit differentiation deals with this whole dy dx. And it leads into related rate word problems, which is going to probably be our first word problem Wednesday. But for now, we're specifically concerned about learning what is going on with our implicit differentiation. So the good news is we're going to piggyback off last week. So if you enjoyed last week's content or you followed that, we will be having a continuation off that, which will be good. So let's talk about exactly what it means to implicit differentiate. So first of all, it's a long title. So implicit differentiation. All right, what we're doing is typically what we originally saw is we take d over dx is when we take our regular derivative. So what this really means is last week is whenever we did the derivative, the d over dx. It means we are taking the derivative with respect to x. So anytime you see this idea, this is the derivative with respect to x. Now, this is important because most of the time when we first start taking derivatives, the y is always on the left side, and you do take the derivative with respect to x because you're only using x variables. And they just say, hey, that y becomes dy dx. Well, the reason that becomes dy over dx is because dy over dx has the meaning of the derivative of y with respect to x. Make that a little bit easier for y'all to see. So the goal here is we're wanting to now solve for the derivative of y with respect to x. It basically goes back to that algebra concept of graphing that you'd always solve for y. Well, in calculus, we're always going to solve for dy dx. Or if we set some other variable, it could be, for instance, like when we talk about related rates with the first word problem Wednesday, maybe we're talking about the radius, so we do dr of dt. Or maybe we're talking about the area, so we use dA over dt. You're doing the respect of the variable, or you're doing the derivative of the variable with respect to x. And that's a concept you really want to keep track of and just make sure that you're paying attention to. So tonight, everything we're doing, we're going to solve for dy dx. Keep in mind, I'm not using a book or anything this evening. I'm literally going to be making up problems, so maybe some of them work out really nicely. I'm not going to go over the top because I want us just to understand the basic idea of what it means to implicit differentiate. So this is a good start of just knowing the difference of what's happening. Here we're taking the derivative with respect to x. This means we've taken the derivative of y with respect to x. So those are important things to keep track of. Okay, so if we start off with a basic problem, we say find the derivative of 3x squared plus 2y squared equals 4. Solve, or find the derivative of, and then when we go through this, we're really going to solve it for dy dx. So your methodology here is the same as what we did last week, where when we did power rule, you brought the 2 forward and then you minus 1. So 3 times 2 becomes 6x to the 1 power, plus you bring the 2 forward, you minus 1, and now you get 4y. But the problem is you're left with dy dx. Whenever you take a derivative of y, you get dy dx. Now, a lot of people ask me, well, what happened? Why didn't that happen with x? Well, it did. And I'll write it out front here, which isn't necessarily proper, but you'll get why we don't actually write it. That's because you get dx over dx. And dx over dx just goes away, so it doesn't actually matter. And then we set that equal to the derivative of 4, which is 0. All right. At this point, you've done the calculus, and now you're on to doing the algebra. So you're just solving this equation for dy dx. In order to do that, the first thing you have to do is subtract 6x from both sides. And I'm actually going to work these out a bit tonight. So we're left with 4y dy dx equals negative 6x. Guess what? Now we're going to come over here and say, hey, let's divide by 4y. Also, sorry, usually I'm a little bit better about color coding. So we're left with dy dx is equal to, can we reduce this? Yeah, they have 2 in common, so this becomes a negative 3x over 2y. And you're done. All right, we're not doing a whole lot of extra steps here. We're still doing the derivative, except now we have this dy dx that we're solving for. And once we solve for it, you are done. All right, right now we're not doing anything with this. This is not application time. This is strictly, hey, find the implicit derivative. All right, this is a very basic problem. We'll do a couple more. But please remember, if you have any questions, if you're watching the stream, always feel free to ask. If you're watching the YouTube video, there's a link below to that. There's all the Math Man Mondays there. Always feel free to comment, leave questions, or you can always DM me on Twitter or ask questions there as well. So our first problem here is just solving for dy dx. Pretty simple and straightforward. So let's move on. Let's move to our next problem. Might need some more room on this one. Hey, what's up, Panda? Panda in the chat. That would be why my board was all weird. Alright, it wants to lean this way. If I lean it, there we go, whatever. So let's do a little bit of a longer problem here. If we have, so same idea, we're going to solve for dy over dx. If we want to do a little bit of a longer problem here, or maybe not even so much longer, but just a different problem so we can kind of see some different things that would happen. Let's talk about doing 6x squared y to the third equals 7x. So in this case, we have a product rule over here. You have a couple options here. Really, you can just ignore the 6 and treat the variables here as if there are parentheses there, and then do your product rule. So we want to go through and actually go ahead and say, okay, let's leave our 6 out here, and then do product rule on the inside. So really, you just have to remember product rule from last week. It doesn't necessarily change anything, but we're going to do the first times the derivative of the second. So that's going to give us 3 y squared. We have to remember we took a derivative of y, so now we have dy over dx. And then we're going to add the second, which is y cubed, times the derivative of the first, which is 2x. And we don't have to put anything there because we didn't take a derivative of y. And then we're still left with this equals, and then the derivative of 7x is going to give us 7. So we have everything we need. So we did the calculus part, and now we're back to solving the equations just algebraically. So really this just takes some moving around, and here you want to think about this as being, now it's going to be 6x squared. Actually, boop, 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 boop. 6 times 3 is 18. X squared, y squared, dy dx, plus 2xy cubed equals 7. I like to write things in alphabetical order, so you don't necessarily have to do it this way. I just think it actually looks better. So we want to keep track of this, and again, this term is by itself for right now. We want to get rid of this whole 2x y cubed term, so we're just going to subtract it. So 2x y cubed is going to get subtracted from both sides. That way on this left side, if you divide both sides of x first, your equation becomes easier. Yeah, it does. I just know most people, they see this and they're going to do product rule off the bat. So like if I would have went ahead and divided by x squared, it would have got easier. Now, it would have got easier in the sense of this side with having dy dx by itself, but then you had to do quotient rule over here. And the good thing about quotient rule on this side is you got 7 over x, and then you, if you know the little trick, it ends up being 7 over, or negative 7 over x squared, which I was talking to my students about today, but some people don't know the little shortcut for that. But either which way, you could do it either way and simplify this side out and then go ahead over here and do the quotient rule. So here, where we were just left off, you could subtract this 2xy cubed on both sides. And when that happens, on this side, you're left with your 18x squared y squared dy over dx equals 7 minus 2xy cubed. And then at that point, you're just stuck with this division. So you're just going to divide this whole thing off, 18x squared y squared, and then boop, 18x squared y squared. And you're basically done at that point. If you wanted to go further, you could separate out the fraction. But in this case, we're not too worried about it. All right, and again, got a little bit off camera. This is one of those problems that's a tidbit longer. So whenever you see that product rule, and Panda was asking in chat, could you divide by the x's first? Of course you could, and then you get quotient rule on the right side. And that's completely fine. It ends up working out to be pretty much the same answer. You might just get some different coefficients because of simplification, but your answer would be the same. You just want to be careful that once you get done with the calculus part, just do the algebra. Don't overthink it. It's literally algebra. The thing that people are going to struggle with in calculus isn't so much the calculus concept. It might be the concept of the calculus. But doing the formulas and stuff, people are generally okay with. People get to here, and then it's like algebra just kicks their butt because they did it 4 years ago. So take your time and go back and review just some common algebra. So now that we've done a couple of these, we can take it a step further and actually give ourselves x and y values to plug in and look at a specific point to find slope there if we want. That's not a huge deal. It doesn't really change this too much, but let's talk about one of the problems from like before with that extra little methodology. Also, Goke knows he's a math teacher in the chat. These kids need to learn some algebra again. Okay, so we went over 2 examples, and really it doesn't get too much harder than that unless you add, more y's. But overall, nothing too crazy. So if we come here and we say, again, solve for dy dx and find the slope at, let's not do anything too crazy, negative 1, 3. I don't know how this is going to work. We'll see. Usually I make these problems out and, you know, things go horribly, horribly wrong. So we have to give ourselves a function here, or an equation. So again, I'm not going to do anything too crazy because I want to go back to this idea. Let's do 4x to the third minus 2y to the fourth equals yeah, why not? 3y squared. Thanks, Rick. It's actually pretty dope. New math tat is pretty sweet. All right. So again, we're going back to this idea of taking the derivative. So you have some options here. I'm going to go with what standardly happens because people see this and they automatically want to do the derivative rather than taking the shortcut because that makes sense. And you're going to go through and just find the derivative as normal. You could definitely get these y's together on one side and group them together, and things might work out better for you. But you know, I'm not gonna go too far there. So again, when you're doing power rule, remember this comes forward, then you minus 1, so you get 12x squared minus 4 times 2 is hopefully 8, y to the third. The other way you can actually go through and write this is instead of writing dy dx, sometimes people like to write y prime. I'm not a huge fan of this because people like to get these two things confused and then they'll go, hey, it's y to the fourth. So we're going to go back to this dy dx. But if you ever see that y prime idea, that's what they're talking about. And then here we're going to get 6y dy dx. All right, remember, we're solving for dy dx. Like, that's the end-all, be-all of what we want. So we want to get these two things on the same side, which isn't too bad for us. We're just going to go through and add that to both sides. So we're going to go and say plus 8y cubed dy dx plus 8y cubed dy dx. And we have our one giant addition problem. Oh no, Gok, is it? All right, so we end up with 12x squared is equal to 6y dy dx plus 8y cubed dy over dx. And again, we want to get to this point so we can factor out dy dx because that's what we're solving for. You could obviously do other factoring with that, but I'd wait until you move everything over to the denominator. So we're going to go ahead and factor that out. We end up with 12x squared is equal to, and then we're just going to take a dy dx out, just like you used to do in algebra if you enjoy factoring. Some people do not. Some people only use quadratic formula, and it makes me really sad. But we're doing calculus, so I like to believe that you've reached the point of being able to factor. Once that happens, you can go through and divide this whole thing off. So you have divided by, and then 6y plus 8y cubed, divided by 6y plus 8y cubed. And we have our little solution there. The good news is, I'm going to erase part of this top part so we can go back and look at some stuff. My board is working pretty good. I like my new board. Okay, so we found out that, let me get this angled better. dy over dx is equal to 12x squared over 6y plus 8y cubed. Okay, so that's what we found out. At that point, you did everything that we did before. You just have one more step of solving or plugging in the -1 and the 3. That's nothing too crazy. You just go over here and say 12 times -1 over 6 times 3 plus 8 times 3 cubed. You end up with -12. Oh man, that's a big number. I've made some grave errors in my life. 27 times 8, so you get 56, carry the 5. 16 plus 5 is 21, so 216, maybe, I don't know, we'll see. 18 plus 2, 16, so 234. Quick maths, y'all. So that ends up to be -6 over 117. That seems really wrong. This is why I don't make up problems. Oh, it's 12x squared. Well, you know, that at least gets rid of the negative. Anywho, that gives you an idea of implicit differentiation. It's really just like derivatives, except you add the extra step of algebraically solving for dy dx, and it doesn't. That's nothing too extraordinary. It's pretty straightforward. Hopefully, either this Wednesday or next Wednesday, I'll be doing a word problem Wednesday. So we'll be doing related rates, which will come back to this, and we'll do some word problems that relate to those. And that will be it for this evening's Mathman Monday. If you enjoyed the content, you can always feel free to hit the follow button. I'll be uploading the video to YouTube as well. There's a YouTube link below with all the other Mathman Mondays on there. And then, like I said before, if you ever have questions, always ask them during the stream. 3 is a factor of 117. No! Alright, sorry. Un momento. I wasn't even thinking. Oof. 29. That's rough. Alright. No! That's why... Okay. Anyways. You can always leave questions in the comments on YouTube. Always ask them in my chat while I'm streaming the Mathman Mondays. You can also go on Twitter and shoot me a DM or, put questions there. I'm always happy to answer them. And then... if you enjoyed any of the deco boards and you want a deco board for yourself, if you ever need that information, shoot me a DM. I'll get you the contact information for the guy I know. Like I said, this board is different from the one I used last week. And then there's also Onyx boards. They do a bunch of different stuff. So if you're interested in anything like that, please let me know. I'll get you their information. I hope you guys have had a good Monday. I'm going to be switching over to some Smite so that way I can practice for my league game tomorrow. And I'll see you guys here in a few minutes. Thanks for watching.